Okay, so today we are going to discuss a very important topic in nuclear physics, that is isospin, or it is also called as isobaric spin, or sometimes isotopic spin. Okay, so we'll be discussing this today in this lecture. Let me start with some observation, some experimental data here, right? If we have two nucleons, let us consider mirror nuclei. We have two mirror nuclei. Okay, we all know what do we mean by a mirror nuclei. Mirror nuclei means those nuclei in which proton number and neutron number is exchanged. Okay, proton number and neutron numbers are just exchange of each other, right? For example, I am taking the example of say for example we have two nuclei. Lithium, I have lithium 37. Okay, this is lithium 37, this is one, and I have another one which is beryllium 74. Okay, beryllium 47, these are the examples. Barium 4, beryllium 47, these are the examples of two mirror nuclei. Okay, if we see these two mirror nuclei, you will never be able to differentiate them in terms of their properties. Okay, if we draw energy level diagram for them, the energy level diagram for these two nuclei comes out to be like this way. Here I am drawing for lithium. This is the first energy level, ground state energy level, and for beryllium, this is the ground state level. Nearly approximately these two energy levels are close to each other. Okay, so ground state energy for this one is 3 by 2 negative. Okay, and ground state energy for this one is 3 by 2 negative. Both have same ground state energies, 3 by 2 negative. Okay, similarly we have the first excited state for this one, and the first excited state for this one also, and the first excited state for both of them is 1 by 2 negative. Okay, so it is 1 by 2 negative, both of them 1 by 2 negative. Similarly, if you go on adding some more excited states, experimental data shows there is some other excited state here, which is 7 by 2 negative for both. Okay, 7 by 2 negative for both, right? Now the question arises, these two mirror nuclei have different proton number as well as mass number. Okay, so whatever is the number of protons in lithium are actually the number of neutrons in beryllium, and whatever is the number of neutrons in this lithium are actually number of protons in beryllium. Okay, so simply we can say, if we consider this nucleus to be base nucleus, हमने क्या किया है इस न्यूक्लियस के अंदर, प्रोटॉन नंबर को रिप्लेस किया है न्यूट्रॉन नंबर से, और न्यूट्रॉन नंबर को रिप्लेस किया है हमने प्रोटॉन नंबर से, तब जाकर हमें ये न्यूक्लियस ऑब्टेन हुआ है. सो इट इज जस्ट अ ट्रांजिशन. ओके, यू कैन से दैट we have just exchanged proton number and neutron number. ठीक है, so when we did so, the properties didn't change. In fact, I am discussing about this energy levels. The energy levels change नहीं हो रही यहाँ पे. ठीक है, अब इस चीज की अगर हम रीजन देखें why it is happening, ऐसा क्यों हो रहा है, तो we have to go to the liquid drop model. Back to the liquid drop model. Liquid drop model contains 5 terms binding energy के लिए, and all those five terms, I need to write them and say what is actually happening here. First term contains this like this is AV and then multiplied by A. Okay, this term depends on A is the mass number. Okay, these two both nuclei have same mass number A, so obviously this term will not be affected when we transit from this nucleus lithium to beryllium. Okay, in terms of mirror nucleus, right? Okay, then second term is like this way, AS. And then we have a to the power 3 by 2. Again, this term wholly depends on the mass number, so therefore again there will be no effect of this on this term by making some transition. Okay, third term is AC, that is Coulombic term, and Coulombic term is like this way, Z square a power 3 by 2. Now this term will change. Okay, ये term change हो जाएगी, obviously ये change हो जाएगी, इसलिए क्योंकि इसमें Z involve होता है. ठीक है, and Z is not same for both. Z is different for two different nuclei. Okay, this term will be variant, this will vary. Similarly, we have other terms, two terms, like I will write next term, asymmetric term, A, that is like this way, that is Z minus N. Okay, Z minus N, then square and divided by some A. Okay, so A is constant. Again, Z minus A will be a constant number. Okay, if you subtract Z minus A or subtract A minus Z minus N or N minus Z, it will be same. Okay, and then there is square, negative term will not affect it. So this term also remains unaffected. And then we have last term, which you know is pairing term. That again depends on A. Okay, that also will not be affected. Okay, the only term which is affected is actually this coulombic term. When we transit, जब हम transit करते हैं mirror nucleus में देखते हैं, तो this term has some effect, ये term change होती है, otherwise all the other terms remain constant. Okay, but ये जो term यहाँ पे change हो रही है, अगर ये term vary हो रही है, so the binding energy should vary then, binding energy should vary then. Okay, थोड़ी बहुत variation तो होनी चाहिए binding energy में फिर. Okay, the variation is evident here, you can see that there is some variation, small variation. Okay, this energy level and this energy level, 3 by 2 of lithium and 3 by 2 negative of this beryllium are not at same levels, there is some difference, so some sort of slight difference. Now why this difference is so small? The difference is so small. Why? Because nucleus में आप जाओगे तो nucleus में आपको मिलेंगे nuclear forces, आपको मिलेंगे. अब जो न्यूक्लियर फोर्सेस आपको मिलेंगे, साथ साथ में आपको कूलम फोर्स भी वहां पर मिलेगा, इन केस ऑफ प्रोटॉन्स आई एम सेइंग कूलम फोर्स. बट वी नो न्यूक्लियस में जो डोमिनेंट फोर्स होता है ना, दैट इज न्यूक्लियर फोर्स. ओके, सो ये कूलमिक फोर्स वहां पर ये हो जाता है, डिप्रेस हो जाता है, वी कैन से ये सप्रेस हो जाता है वहां पे. ठीक है, तो अगर ये कूलमिक फोर्स वहां पे सप्रेस हो रहा है, विच मीन्स दैट इट विल हैव वेरी लेस इफेक्ट. ओके,